Hidden in 27 kilometers of tunnel, 100 meters underground, is a colossal machine. A construction so enormous it has taken over 15 years to complete, pushing engineering to its very outer limits. It's the world's biggest computer game, where the winner gets to see the very beginning of the universe. Gargantuan cameras will take 40 million shots every second of this groundbreaking moment. This is the Atom Smasher, the biggest scientific machine in the world. Straddling the European border between France and Switzerland at the European Organization for Nuclear Research, the Large Hadron Collider is the most ambitious scientific experiment ever attempted. A 27-kilometer enclosed ring, punctuated by 4 enormous camera-like detectors, will mimic and record events seconds after the Big Bang, in the hope of finding the answers to life, the universe, and everything.
Behind me is one of the biggest experiments in the world. It's the Atlas detector, and it's like an enormous, it's a camera really. It's a camera that takes pictures 40 million times a second.
I've essentially spent my whole professional career working on CMS for the past 15 years. So I'm really excited by the prospect of actually getting this thing up and running and getting some physics out of it. And it really is just the start of the adventure. It's really just beginning now.
CMS and Atlas are not identical, but they are built in parallel, so both can capture the results of these catastrophic collisions.
We don't know what we're going to find. We don't know the answer. So when we do think we've found something, having another experiment that's based on similar principles but done in a different way, if they also see the same thing, we can compare the two and have a really good idea that what we've found is real and it's not just a fluctuation, that it's not something random.
We're looking for precisions of a millimeter or less on objects that are 14 meters across. And so this is pushing engineering to the limits of what can be achieved today.
Better known as CERN, it's the largest scientific research project in the world. More than 7,000 scientists, half the world's particle physicists, use its facilities. CERN was established near the French-Swiss border outside Geneva in 1954 to study the building blocks of matter, the component of everything in the known universe. They haven't yet discovered all the answers, but in the process, CERN has given us the World Wide Web and highly advanced medical scanners. The resting place for the mighty Atlas detector is so big it could hold the nave of Paris's Notre Dame Cathedral. It took 6.5 years to complete the 53-meter long, 27-meter wide and 24-meter high CMS cavern.
It weighs about 12,500 tons in total, and there's really no crane in the world that can actually lower down 12,500 tons 100 meters. In effect, a big button says go, gets pressed, and the whole thing works. It's, of course, the principle of it, at least.
At the very beginning, people said, yeah, we'll build this thing with all this high tech and we'll bring it down, we'll test it in the lab, we'll bring it down, we'll turn the switch, and it'll work. Well, one thing that we learned is that does not work. We test in the lab, bring it here at CERN, test it at the surface, it doesn't work. We fix it at the surface, we said, okay, it's certified, bring it down. We bring it down, test it, when we bring it down, it doesn't work. Okay, so we're constantly, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, we're testing and repairing. And stupid stuff that's breaking, it's the connectors, it's the screws that we forget about, it's the wires that aren't soldered well enough. The high-tech stuff seems to be fine, but it's the mundane things that you just take for granted that fail. The physicists are so demanding. They need this precision to not miss any energy going through gaps, that it has to happen. And at the end of the day, human beings, being what they are, solve the problems. My prediction is that they're going to be in for just the biggest surprise as we were. When they turn on, their stuff is not going to work. And they'll be at that point probably for the next year.
There's still a lot of work to do, but we're on course. It's all going very well.
Nothing works. Every day it's something different. We're now right at the center of collision. So the protons, if I look that way, protons are coming at me. If I look that way, protons are coming at me. And right in the center here is where they'll collide. So all this equipment where I'm kneeling is to measure the high density of particles that are going to come out.
Huge refrigerators filled with liquid helium keep the collider at minus 270 degrees Celsius. It's the coldest environment in existence, colder than even deep space. Farms of computers will count and trace the multitude of particles produced by the collisions, generating 15 million gigabytes of data annually. The Large Hadron Collider and its giant detectors have broken every engineering and scientific barrier and had an enormous impact on the lives of the people involved. But with the job well done, it's time to move on. Having taken a decade and a half to build, at a cost of over 3 billion euros, the Large Hadron Collider and its giant detectors will only have around 10 years to find the answers to life, the universe, and everything. After this, the world's biggest atom smasher will reach the end of its useful life, and a new collider will take over.
Large Hadron Collider, the biggest machine ever built by human beings. The experiment was designed initially in the mid-'80s and has taken this long to construct. There are 10,000 people of over 100 nationalities. That includes countries which are mortal enemies of each other, like India and Pakistan and Georgia and Russia and Iran and Israel, all have physicists working on this machine. These big blue things are 7-ton superconducting magnets, which have to be cooled with liquid helium to the coldest temperatures on Earth, colder than empty space. There are 100,000 computers connected all over the world to deal with the data. In fact, the World Wide Web was invented at CERN so that physicists all over the planet could share the data. We are reproducing the physics, the conditions, just after the Big Bang. We're doing it in this collider, and we're reproducing that so we can see what it was like when the universe just started. We study particles because just after the Big Bang, all there was particles. And they carry the information about how our universe started and how it got to be the way it is and its future.
I can remember walking in and just being like, just stunned. I mean, me stunned, already kind of having an idea of the magnitude. People tell you, oh, it's 5 stories tall. And you go, oh, okay, 5 stories tall. And then you see 5 stories completely filled with microelectronics. All custom designed, all hand soldered. It's like as if it's a 5-story Swiss watch.
It's being called the largest scientific experiment in history, and some say one that could cause Armageddon.
It's the strangest experiment ever, mankind's most ambitious attempt to understand how we all got here.
Thousands of scientists from around the world have spent 20 years designing an extraordinary machine. It cost more than £5 billion and will be switching on very soon.
This is a Genesis machine, a window on creation.
A group of fringe scientists believe the collider might create a black hole that could swallow up the Earth, and they filed suit to stop the project from going forward.
5, 4, 3, 2, 1, Now. No beam. 5, 4, 3, 2, 1, 0.
The world's largest atom smasher, the Large Hadron Collider, is to be shut down for at least 2 months. CERN, the European Organization for Nuclear
Scientists
Research.
at CERN are trying to put on a brave face. A faulty electrical connection between two magnets led to a ton of liquid helium being leaked into the 27-kilometer tunnel. The first high-speed particle collisions were due to take place later this month. The goal now is simply to get this vastly complex machine working.
The goal of this is that it will be in even better shape for next beam.
We've got the beams going around again. The magnet repairs are holding up well. And our next challenge is to take these beams up to high energy and collide them.
Okay. The Higgs is unlike any other particle. It's the linchpin of the Standard Model. Its theory was written down in the 1960s by Peter Higgs and a number of other theorists. We believe it is the crucial piece responsible for holding matter together.
We may discover additional forces, where we may discover additional space dimension, the Higgs boson. We may elucidate the mystery and the origin of the universe dark matter. And who knows, perhaps nature has prepared some nice surprises. So we should watch that one, our trigger rate, this one, the separation bump, and event display. Okay, these are the 3 screens. If you have 3 eyes, one there, one here, and one over there. You are still at 1.
At Atlas and LHC and CMS and all those places has suddenly changed. I mean,
I keep telling to the student that it's much better to be in that situation than in my situation, right? In which I've spent 40 years on nothing. On nothing, you see?
Coffee is a very serious business in the life of a theorist. It's not like physics research where you can wait for 30 years before you know if you are right. Within a few minutes, it pays off. If you succeed, it's great. If you fail, you get to try another one in another minute.
This is one of the few truly perfect academic institutions in the world. I mean, there's no excuse at all not to think and work and get things done. That's its only problem. There's no excuse at all not to think and work and get things done. You can't blame it on anything if it doesn't work.
And I think all of us and all of the people outside watching it in the different meeting rooms, everybody who was involved and is involved in the project can be proud of this day. Okay, enjoy it.
Scientists this morning announced they are almost certain they have discovered what's being called the God particle.
It is not every day that you see a whole bunch of scientists standing up with champagne bottles and cheering.
Now, the God particle, we physicists wince when we hear those words.
It's the last piece of the puzzle physicists have been looking for decades.
I did feel a sense of pride when the Higgs was announced. But I felt a sense of pride for humanity. That, you know, we little people on a little planet with tiny brains can go so deep and understand what happens. Now we're talking about subnuclear distances 1,000 times smaller than an atomic nucleus. Nevertheless, we can get things right, and just the power of the human mind.
The most important first lesson of the discovery of the Higgs is that physics works.
The Higgs, on the one hand, completes the most successful scientific theory we've ever had. On the other hand, opens the door to some very major paradoxes that we now must address.
There is a very nice sentence in the Divine Comedy by Dante who says, nati non fummo a viver come bruti, ma perseguire virtute et conoscenza, which means We were not born to live as animals, but to pursue knowledge and virtue. So science and knowledge are very important. Like art is very important. It's a need of mankind.